Hello everybody, in today's lesson we're going to be talking about derivative laws and what chain rule is. So first I'll start off derivative laws. Pretend you have a constant derivative, any constant is always 0. Now if you have a constant times a variable, the derivative of that would be the constant times the variable's derivative. Now this directly ties in with product rule. So if you have two functions, let's say u and v, and you want to take the derivative of that, it's u derivative v plus, there's no minus, u times v's derivative. And you can use product rule to prove this. Now with quotient rule, with two variables dividing by each other, and take the derivative, that is u derivative times v minus u times v derivative divided by v squared. And finally, addition and subtraction. So when two variables added together and you take derivative of that, it's just this derivative of those two variables. So you just really have to memorize these laws for derivatives, and that's pretty much it. Now focusing on chain rule. Chain rule at first might seem like a complex subject, but it isn't really. So what it is essentially, it's power rule, but you also have to chain it down all the way down to its final function, like this form. So if you have xn, you do product power rule, and then you take the derivative of that function again. So for example, when we want to take the derivative of sine 2x, we know the derivative of sine x is cosine x, so it's cosine 2x, but we also have to take the derivative of this inside function, so we have to take the derivative of 2x. So that's pretty much what chain rule is, which equals cosine 2x times 2. Now, if let's say if the equation is a bit harder, so let's say it's tangent 3x squared, and you want to take the derivative of this. Well, you know the derivative of tangent is secant squared. So it's secant squared 3x squared. But you also have to take the derivative of this thing inside. So that is times 3x squared's derivative, which will be secant squared 3x squared times 6x. And this is pretty much chain rule.